Alright, chapter 5.6 is going to be graphing tangent cotangent functions today. First thing I want to tell you about tangent and cotangent that's different than sine and cosine is the period of tangent and cotangent begin with is pi. So normally with sine and cosine it's 2 pi over c to find the amount per dash. Here we're going to go pi over c. Alright. The other thing that's going to be different in graphing tangent and cotangent, I'm going to go through 2 periods. Just it allows me to get at least one full picture of it. So basically tangent and cotangent have this look to it or this look to it, one or the other, depending on signs and stuff like that. They look like those, and there's asymptotes on either side of these graphs. So it's that might be a tangent graph, this might be a cotangent graph here, let's say a different asymptote like that. But if we went through only one period, we might start here, go up, have the asymptote, and then do that, and then it's just, you're not going to see one full picture of it. So I like to go through 2 periods to make sure we at least see one of those, if not 2 of those pictures. With that in mind, I just know that where we did 4 dashes on sine and cosine, we're going to be doing 8 dashes equally spaced on this. We're still going to do period divided by 4 for the dash increment. So period divided by 4, so we're going to go through 1 period, then a second period to go through all 8 dashes. All right. Label all the dashes. Again, we can do that either individually, labeling every dash, or put x colon and then whatever you're going up by per dash. The same with the y-axis. With tangent, there's going to be vertical asymptotes. Always graph those first. They happen at the 2nd and 6th dashes. And positive b on the 1st and 5th. Negative b on the 3rd and 7th. When it says positive b, negative b, if b is a positive number, positive b is a positive number. If b is a negative number, then positive b is a negative number. So positive b just means whatever sign b is. Put a dot at the 1st and 5th. And negative b, put a sign at the opposite sign at the 3rd and 7th. And then 0 at the 4th and 8th. And then connect the dots with a smooth curve. Don't cross over any of the asymptotes. So, bunch of words, they make a lot more sense when you actually see them put to use, so I just want to kind of go through that quickly. Just the 2 things we're going to care about are b and c. They're going to look like the same b and c we did with sine and cosine. It'll be some number tangent of some number x, or some number cotangent of some number x. Oh, here, -3 tangent of x. So you can see here I put my vertical line for the y-axis here, and my horizontal line. 1, 2, 3, 4, 5, 6, 7, 8 equally spaced dashes there. I will recommend put a dash not all the way at the very top and bottom, just kind of just a ways up, because what happens at pi over 4 and 3 pi over 4 and 5 pi over 4 and 7 pi over 4, those are the normal spots on the 0 to 2 pi region. Tangent is either positive 1 or negative 1, then it gets bigger or smaller. So you kind of want to go up and then really up, you know, so don't put it way up here or else you're going to way up and then it just looks really weird. So not super far up the line there, leave yourself space above and below. So what I can see from this is the value of b is -3, which means that 3 is equal to the stretch constant. All the stretch constant does is tell me where 1 would happen, where 1 normally happens. It's going to now happen at 3 and -3. All right, so 3, -3 are the numbers that go on the y-axis, and I'm going to keep it at 0. We're not moving off of just a basic center line of 0 at this point with tangent or cotangent. The second thing I can see here is that c is equal to +1. Number in front of x is understood to be 1, which means the period of this thing is just going to be pi over 1, all right? But the per dash is going to be pi over 4. So per dash. Okay. So even though I have 8 dashes, keep in mind the period, the per dash is going to be the same as it was on sine and cosine. So pi over 4, 2 pi over 4, 3 pi over 4, pi, 1 period. Pi over 4, 2 pi over 4, 3 pi over 4, pi, a second period. So keep that in mind. Notice I'm doing an x colon pi over 4. I didn't do a y colon anything. I just put that's fine too if you want to go that route. I think most people don't have any problem having these here, but you know, having the numbers along there, you're going to have to draw your lines through them. Sometimes it causes it to look a little ugly. All right, so the next thing is to just start placing things where they belong. The first thing I mentioned was asymptotes. Looking at vertical lines, dash lines that go through the second and sixth dashes. There's my second and there's my sixth. Pretty close. I'd like you to use a ruler when you do it on your own. That's not good. There we go. All right, so second and sixth dashes. We're supposed to put a dot at positive B, and notice positive B is -3, right? Whatever B's value is, that's what represents positive B. So on the first and fifth dash is positive B, so I'm going to go here and here. And spot at -B at the third and seventh dashes. 1, 2, 3. Negative B is going to be changed to sign +3. 4, 5, 6, 7 right here. And then finally, we're supposed to put one at 0 at the fourth and eighth dashes, and it should be the first, like, so right there. I don't know, did I say the very, like, at the,
yeah.
or, okay, so there, and then the fourth and the eighth. All right. Now, just to look, we got one full picture right here, right? This is chopped, this is chopped. Sometimes it's easier to graph the full one first so you can get an idea of what everything else is supposed to look like, because it just repeats itself. So if I know it's going to come, what it's going to do is going to kind of come down and then back around like that. That's kind of what you're looking for. And then the part that goes off towards the asymptote continues off towards the asymptote without crossing, like so. So that's what the picture is supposed to look like. And that gives you a better view of what the rest of it's supposed to look like. So from 0 down, it's supposed to kind of curve down like so. And here it's supposed to curve kind of up like so. And really, I mean, we didn't extend it further, but it would start going down like that and would start going up like that. Like that. All right. And again, that's 2 full periods, but again, it only gives us 1 full view of the graph because, again, it's chopped there and there. So again, that's why I want to go through 2 periods so we get at least 1 full view within 2 asymptotes of one of the regions here.